right, so this is Algebra 2-9, last lesson of Unit 2, looking at adding and subtracting radicals. And we just looked at this sentence above that says sometimes radicals need to be simplified first before they can be added or subtracted. So that's what we're looking at in this first example here. Just by glance, I can see that my numbers under the radical, the 18 and the 128, they are not the same. So I cannot just add these. I cannot just add these to, get 3 square roots of whatever 18 plus 28 is. I have to simplify those radicals first in order to see if I can get them to have the same radicands. So I know in my head I'm looking for factors of 18. And I know right from the beginning that 18 has 9 and 2 in it, as well as 6 and 3. But the important one I want is the 9 and 2, because that 9 is a perfect square. So, get my keyboard off. There we go. So I'm going to take that 2 square roots of 18 and turn it into 2 times the square root of 9 times the square root of 2. That 2 coming from the front 2. This other 2 inside the radical coming from the fact that 9 times 2 gives me 18. Not losing my plus sign in between. Now I need to look at my factors of 128. Those not so easy to do in my head, so I'm going to jump to my calculator. Hit that y equals button, 128 divided by x, second, and table. So I've got 1 and 128. Ooh, 2 and 64. I'm thinking that's going to be a good one because 64 is a large perfect square. I do have 8 and 16 that I can use. But again, remember, I want the largest one. So that 2 and 64 is the one I'm going to use. So I am going to break up the square root of 28, or 128, into the square root of 64 times the square root of 2. And that is a good thing to notice, or a good thing to recognize here, that both of those have that square root of 2 in them, which is what I wanted to get. So my 2 stays out in the front. The square root of 9 comes out to be a normal 3, and the square root of 2 stays. The square root of 64 is 8, and again, if you didn't know that, you're just coming back here and you're putting that in your calculator. Square root 64, 8. And square roots of 2, and again, you can check that square roots of 2. Say you don't recall if that's perfect or not. You can clearly see from the number you get that it is not perfect, and we want to keep it in the radical. 2 times 3 on the outside, because multiplication comes before addition in order of operations, gives me 6 square roots of 2 plus 8 square roots of 2, and 6 plus 8 is 14 square roots of 2. Just like 6x plus 8x would give me 14x. You're adding square roots of 2 and square roots of 2. You end up with square roots of 2. You're adding apples and apples. They stay apples kind of thing. We'll take a look at the next example.